just ask, how many people here are in startups or early stage companies? And how many people here work for OEMs or large corporations? And how many are academic, university related? Trine is exactly what you told me it would be. The ratio is exactly right. I just wanted to double check. My role is very easy as moderator. We have a great panel and we have a great audience, and I just need to make sure that I don't get in the way. So 3 of the people up here, 4 of them you've heard from. 3 you have not heard from. And these are MIT-connected startups and early stage companies. Hard to, again, Vecna's not really a startup. It's 17 years old, right? We don't call 17-year-old companies startups. But I want to give them a chance to introduce themselves, introduce their companies, and make any comments that they'd like to on the material that came up this morning. So, George, why don't we start with you?
Okay, thank you very much. So I'm George Arnold. I'm CEO of Tercio Solutions, which is a company that provides advanced software that dynamically schedules and optimizes real-time manufacturing operations involving machines, robots, and people. One of our co-founders is Julie Shaw, a professor in the Aeroastro department, and we're leveraging about 5 years of, let me characterize it as AI research on human-robot collaboration. We're at prototype stage. We're working with a few very large companies and industries ranging from aerospace to metal fabrication. And really our secret sauce are computational algorithms that allow us to schedule activities orders of magnitude faster than conventional techniques. So for example, if you think of an application where you have a mobile robot who's assisting a human operator, our algorithms allow the robot to respond to what the human is doing or instructions in real time and sort of optimize its operations. We're growing. We're looking for people. So if you have resumes, please give them to me after we're done. So thank you.
Thanks, George. Christoph.
Hi, so I'm Chris Mandy. I work with Formlab. We are a 3D printing startup. We're about 3 years old. We make 3D printers. This is on now. We make 3D printers, so the product allows designers or architects or engineers to prototype their parts. It's a desktop 3D printer that costs $3,000 or so, and is about on par with the existing $15,000 to $20,000. Sorry. So our product is a 3D printer, just a reminder. We make a printer that is about $3,000, is on par with a $15,000 to $20,000 machine in terms of resolution, speed, etc. And so the company is 3 years old. We launched on Kickstarter. And from that point on, we really have been living the manufacturing dream. This is, starting on Kickstarter with 10 people. A month later, we have millions in sales and thousands of customers and have to launch a product pretty fast. And our product itself is not that mature. We've made about as many 3D printers with our technology as have been made in the past before we launched. So there are really opportunities to bring down throughput or cost or yield by several high levels of percentage points simply by using simple things like clever ideas like Internet of Things or connected devices on our manufacturing line. And so in this context, I think our product is both a manufacturing enabling device that is connected to the internet as well as a heavy user of automation and Internet of Things.
Thanks. Daniel.
So my name is Daniel Theobald, CEO of Vecna. Just briefly about Vecna, I'm really here representing the mass robotics effort. Vecna is a world leader in patient self-service technology, and in our robotics area, we have one of the most complete lineups of logistics-based robotic solutions. So robots that move things from point A to point B in a manufacturing facility, a hospital, a order fulfillment center, et cetera. There are a lot of people here actually in this room that have contributed a lot to the mass robotics effort. Shout out to Liz, who's brought a lot of leadership and expertise, and Ty, tremendous amount of time and leadership to the effort. The one concept that I want to make sure to leave here today, and we'll talk about it, I hope, in a little bit of detail, is this idea that robotics is this cross-cutting enabling technology that is going to allow so many of these things to happen. Advanced manufacturing, biotech, et cetera, across all these industries. What we're going to see is that over time, the concept of robotics as a separate thing is really going to dissolve. Internet of Things, we're not going to really be talking about that. There's going to be an overall convergence of technology that is really going to allow us to really move the needle forward. And one of the things that we're trying to do with Mass Robotics is make sure that we collaborate as an ecosystem here in Massachusetts to really be the world leaders in bringing that convergence together and making it happen. And then, of course, benefiting from that as a region, but then also being able to really steer the way technology provides value throughout the world and making sure that it ends up being a good thing for the human race rather than just yet another economic or industrial boom where we have a lot of people who make a lot of money, but maybe the world's not so much better off than as it could have been if we did it right. So that's one of our big motivating factors is let's work together, let's collaborate to really steer this in a direction that makes a lot of sense for the future of this planet.
Great, thanks. So one of the, when you look at all these technologies that we will refer to in the topic, the computing, the communications, the sensors, the data analytics, tremendous opportunity to revolutionize manufacturing and improve the competitiveness of the world, of our country, and certainly of this region. But there are obstacles. There are some companies and some industries that adopt innovations rapidly, and there are others that do it slowly. There's some companies that do it rapidly and some slowly. I know when I was selling automation systems to Intel, if we came up with a new idea, the next day we had an order for it, and the day after we were late. That wasn't the case when we would go to the pharmaceutical industry, where they would put it into their budget for next year. And then the following year is when the budget would get approved, and then they would have money for the machine. But different industries are different. So I want to just pose it to the panel. We can go and start with you, Scott, in terms of what are the obstacles to the adoption of these kinds of innovations?
Well, I think especially as a company grows, Bosch is probably more on the pharmaceutical side than it was on the Intel side in what you described there. Rolling things out into a large global manufacturing environment or network can be challenging. And you get a lot of neat ideas and a lot stands in the way between that idea and having that in the hands of every single person. I mean, I can think of an example, something as simple when we come out with a new control product, just the education of a few hundred regional tech centers to be able to support that technology, to be successful at it, means a lot more. You're a small startup, you rifle, you pick a few places, you go after it. You're a large company, and the minute you sell it in Chicago, you're expected to be selling it in Bangkok. And to just think about all of the things that happen in between there can be quite a challenge.
And so can you suggest also the ways that Bosch overcomes those challenges?
Well, it's lots of people, lots of work. I mean, when a new product, there's a very complex, detailed product launch cycle that we go through that involves a lot of parties, mechanized, meeting often, documentation, training, all of those. I'm going down that path thinking now that we've got something cool, we want to get it out in the hands of everybody, but we don't want it to be a flop. Those are the areas that we really have to strengthen up. And it's an area that I've seen some companies go light on, and you pay for it.
Kristen, you are working in a whole range of very innovative technologies. How do you see them entering the marketplace?
Yeah, I think in my experience and also what I've learned from working on these manufacturing institutes that cover many sectors is one obstacle is the supply chain connectivity not being there. If you use the fibers and textiles for the Internet of Wearables as one example, wearables, folks in the fashion market, right? They're candidates for this, but they don't have their R&D centers. They don't know how to adopt or judge even whether they want to take on new technology. So getting this whole supply chain connected so the decisions can be made and actually produced is a challenge in a fragmented ecosystem like that one.
Liz?
Well, I think I go back to this point about the scale-up process. And if our system, writ large, now believes that innovation is driven largely by a smaller startup environment, which obviously our large companies are still heavily engaged in R&D, but they're also looking outside, and that ecosystem has been largely driven by risk capital and by the venture community. And what we've seen in talking with a whole range of companies, particularly coming out of MIT, so they have a heavy engineering bent, is that a lot of these technologies aren't necessarily VC friendly. If the VC community, has a typically wants to be, exit within 5 to 7 years, and even in that case, we found VCs who are sticking with companies much longer. But even there, it's not the right vehicle, it's not the right capital structure for these kind of long-term technologies that require the long time horizon as well as the CapEx, not only to get through piloting and prototyping, but demonstrating at scale, right, requires a whole new set of investments. And what we found with a lot of the companies we spoke to is that either they're turning to the strategic partners, which we see a huge push toward trying to find that partnership, which may or may not lead, takes a variety of forms. The other point that we've seen is that other countries are very aggressively trying to build their own portfolio and will provide low-cost capital, perhaps non-dilutive capital, training, grants, whatever, so that you might come and try to scale in different parts of Asia, et cetera. So I think long-term, that is something that we have to figure out and do better with, and it's de-risking the technology, shortening the time frame, all of those things, but also I think this issue of capital and how we do this is interesting.
Great, thanks. Brian, the Laboratory for Manufacturing Productivity has tremendous range of technologies. How do you see what do you see as the barriers to adoption?
So I'll pick up a little bit on what Liz just mentioned. So manufacturing in many sectors is how innovation is rooted into an economy, writ large, but also for individual companies. And so the professional capital market, I think, may be biased by the internet era. If your third line, your business plan, we're going to go manufacture in China, then you're doing something wrong. So we've worked with a number of companies startup companies that have said, wow, we didn't realize the value that we could actually capture if we were the ones figuring out how to make the thing that we wanted to make. And so it's not exactly the question you answered or asked, but that mindset and that perspective that as a startup company, there is a lot of value to retain the manufacturing process, to retain the development of the equipment and the processes to go hand in hand with the product that you're making. And I think that is sort of instrumental in allowing a company, but also our local economy to better capture the technologies that we're talking about commercializing.
And it's helpful to have your manufacturing people and your engineering people
Hand in hand, side by side.
working together, particularly if you're developing a very complex manufactured product, particularly these days, products that are smart. In other words, we're dealing with both manufacturing processes that are smart, but also manufactured products that embed these technologies in it for ultimate customers. George.
So we've had experience dealing with two types of environments. One I would characterize as a greenfield environment where you have a company that's launching a new technology, new product line, whole new manufacturing process, new systems. And there, the approach of having that company as a strategic partner, I mean, that really works well in terms of this long-term investment and the commitment to getting it to work over time. There are a lot of companies, though, that are trying to survive and improve their operations, and they can't just start fresh. They're working on improvements to existing products and manufacturing operations, becoming more agile, building to order, and so forth. And there it becomes very, very difficult because introducing a new technology into a working manufacturing system is a little bit like trying to change the engines on a 747 as it's flying. So, a couple of things that we've seen that work. Some manufacturers have test environments for their process, so they have kind of a playground into which they can introduce a new technology, shake it out before it gets deployed. And another issue that Scott touched on earlier, which I think is really important, is standards, especially as we move to Internet of Things, where you need data connectivity and transparency. You can't do that without standards. So somehow, getting the manufacturers to move towards implementation of standard approaches is really critical.
You and I talked before about the difference between incremental innovation and disruptive innovation. If you're going to shift a factory to run on your software, it's the whole factory that has to run on that software.
Right.
So the test environments are something that some of your customers are utilizing?
Yes.
Chris.
So I think that the barriers to adoption of automation or connected devices technology is not so much in the hardware side, but really in the data scrubbing and data processing side. So it turns out it's not that hard to turn whatever hardware device or manufacturing process you have smart. It's easy to connect it to the net. It's easy to get the data off it. But it's actually really hard to just take all of this data and process it in a way that's intelligent. And doing this in-house is hard enough. But if you're doing this across the full supply chain, whether it's your own suppliers or trying to give information to your customers, it's even harder. And when you talk about either standards or Internet of Things, the low-tech, simple version of this is the barcode. Right? Barcodes have been around for a very long time. The amount of value you get out of just knowing the batch or the timestamp of whatever you've manufactured is huge. There are standards for barcodes that everybody knows about. Yet basically, most of the things that you own that have been manufactured don't actually use a barcode on them at any point in time. And that's because it's just very hard to pull that data off and use it somehow intelligently within a system. So at Formlabs, we're 25-year-olds who've developed all of the technology. Our whole life has been spent with data on the cloud. And when we started, we immediately launched a manufacturing software that is run on our manufacturing line that processes all of our data and that lets us see real time what is going on at the factory, what the problems are, et cetera. It also allows us to see incoming material, exiting material, the whole dream of what you would want to know about your factory if you're working either remotely or even on site. And this whole architecture exists, yet it's actually the hardest part of changing this or incrementing this or getting more out of it is simply processing the data. We have thousands of data points on everything. It's all unclean data that needs scrubbing, and all of that data needs to talk to each other so that we can actually get something out of it.
Yes, so I'll make two brief points to really bring into focus this question on standards and interoperability. The short answer is to what is the barrier to adoption? It's us, right? It's us in the sense that we oftentimes focus on the wrong things. And let me give you an example. One of the biggest barriers to adoption right now for our robotic systems, these are robots that operate in buildings, they need to use elevators, is the elevator integration, right? It's not the robot, it's not the value proposition of the robot, it's the fact that the robot has to use the elevator, and that's hard. Why is that hard? That should not be hard these days, right? So Vecna went out, we developed an elevator integration box, so we solved the problem for ourselves. But then every other robotics company that needs to solve the elevator problem goes and does it themselves as well. And so I'm having a conversation with some of these other robotics companies, and some say, yeah, absolutely, we need to stand. But others say, well, this is a strategic advantage for us, right? I'm like, well, hold on a second, right? If I had to buy a computer and I could only run your software on it, I wouldn't be buying that computer. And it's really naive for us to think that we can actually develop an industry without this kind of interoperability. You should be able to buy a robot from any number of companies, and those robots should be able to enter your building and use your elevators. That should not be something that we're trying to use as a marketing advantage. And I think that's a really important point, and that's just one example of hundreds, if not millions of those examples where we need to be collaborating and working together. Openness, standards, very, very powerful for us. And then the other point is, what are consumers going to expect of manufacturers in the future? It's what we call mass manufacturing in quantities of one, or others have called it mass customization, right? So we ran this program at Vecna with some MIT interns not too long ago. We said, your job is to allow somebody to get on the web, order a product, or customize a product to meet their unique needs, order it, and receive it without having any human beings involved in that process. And we did it conceptual, and we faked some parts of it, but I think we can all predict the future that this is the way it's going to work, right? You are going to expect to be able to order something. You're going to expect to get exactly what you want. I want shoes that actually fit, by the way, and we have all the technology to do that. And then I want it fast. So we're going to get these lights-out manufacturing boxes. I won't even call them buildings now. They're probably going to be boxes where you're going to order stuff. That stuff is going to be built, 3D printing, you name it, and then you're going to get it. But that can't happen if we don't start to work together to really establish these interoperability standards, if we don't start to think about how we can get out ahead of that curve and make sure that we own that as a region and be able to drive things in that direction.
So So sticking with the topic of standards, because that's very important, particularly for early stage companies, particularly when the standards aren't fully baked. How does an early stage company figure out which of these proto standards they're supposed to follow and make sure that they are not caught either in or outside the standard? And sometimes standards encourage innovation, and sometimes they discourage innovation. So Scott, I'm going to start with you. You know, you're the only OEM strategic on this panel, so it's kind of appropriate. Standards often come from the ultimate customer, which is you guys. So how do you see the development of standards in a way that ensures quick adoption, but also doesn't discourage innovation?
It's not an easy answer. I think in standards development, I talked about Industry 4.0. It's probably a great example because when that was considered a strategic direction by the German government to remain competitive in manufacturing through this century. And there was, if any of you follow the trade press, you notice at the last Hanover Fair there was a big announcement on some of the changes in the organization, and really that was to make it a little bit more nimble. Because I think this is more going into personal opinion now, there was almost too much time being spent in writing standards and not enough in deploying new technology, which is the one end you're talking about hindering it. On the other extreme, there is a company that will make, just by themselves in their own little bubble, a proprietary system, put it out on the market, doesn't work with anything out there, and you find out, like you said, is usually the case, everybody thinks I've got a secret, and you really don't in most cases. Somebody else is doing something very similar, and you don't talk, and you've got to kind of walk the line with the standards. Some of them that we've participated in, we try to do a quick kill, and at least the things that everybody can agree on right off the bat, standardize them. But don't lock down the standard, especially in communication standards, make it extensible somehow, and that's risky to do. If you don't do it, the standard will die, because it will probably be obsolete by the time the ink is dry or the bits have settled in the hard disk. But if you don't monitor the extensibility too much, you'll have a lot of people moving off, so you have to monitor that standard as you go along, and it's not an easy task.
Is this a Bosch-specific standard, or do you have industry associations that are driving
Lots
this?
of industry associations on different areas.
So there's perhaps another problem and challenge, which is multiple industries. Each one has its own needs. Certainly the
course.
semiconductor industry did this
They have one.
many years
The
ago.
packaging
and
group has
in fact,
one.
they called it SECS, which we had lots of fun in the industry referring to as sex standards. And if you overheard people in the semiconductor industry talking about it, you would totally misconstrued what they were talking about. It was very boring, and it was just communication protocols. More comments on the issues of standards?
Yeah, so just one of the ways that the landscape has changed just in the past couple of years in standards is that the Advanced Manufacturing National Program Office, and we have one now as a country, was put in NIST, the National Institute for Standards and Technology, and that wasn't an accident. So within NIST, they're really restructuring to be more nimble about helping to set those baseline easy kill standards with industry organizations more quickly. So there's a much more receptive organization now to setting those standards that everyone can agree on, getting them in place and letting the industry grow. So I think that's a good development in the past couple of years.
Yeah, and just a thought on that. I was actually just on a call with NIST about the type of standards I was just talking about. And I think the word standards is perhaps an overloaded term in one sense. And I think, you know, what I saw there was we talked a lot about safety and certification, and those are all really good and important. But, you know, I got my hand up. I said, guys, this is all very helpful, but we need to think about things like interoperability, elevators, you know, all these type of things. And it was like a light bulb had turned on for them, which I was really grateful to see. And so we're going to start working on that. But really what we need is collaboration, right? Collaboration ultimately creates the de facto, the flexible standards where we are able to work together as companies and organizations and industries rather than have this, you know, we've seen that openness works now. You could just look at numerous case studies where openness, sharing, collaboration produces far better results. And the thing that frustrates me quite often, and New England, we're not so great at this a lot of times, is there tends to be a really strong competitive aspect. And, you know, I'm going to get all this, and I'm going to have my, my big launch, and I'm going to make tons of money, and I'm going to be rich. And we forget that that's a very small pie right now. And we see a lot of squabbling over crumbs that are falling off of this pie, when that pie, if we were actually collaborating and working together, could be literally orders of magnitude bigger. And so I think it's just very important that we're very pragmatic about, yes, what is competitive advantage, what is intellectual property, versus what are the things that we should just be sharing and giving back and contributing to grow the whole pie as quickly as possible.
So just in the interest of full disclosure, I should state that my previous stint before joining Tercio was I was director of standards at NIST for 8 years. So very, very happy to see all the positive things people are saying. But,
I did not know that.
but you know, it's an interesting question because participating in standards activities is costly, right? But it's less costly than it used to be because a lot of activities are now done electronically. You can participate without going to meetings. You don't have to be there. We talk about having standards makers and standards takers. You know, if the standard is just something you need to comply with to fit into an ecosystem, you don't need to be the standards maker, so you can participate at relatively low cost. But startups especially just don't think about this. They're just sort of, you know, blind to this whole, you know, area. But it really is important to become involved, to be able to fit into the market and add value.
It is a difficult bandwidth challenge because a startup can only work on the essential things, but participating and being aware of the standards process is really important. Brian.
I would say from a startup perspective, just an industry perspective, it is strategic and it is evolutionary. So you as an industry, you wouldn't want competitively to start with standards when you identify that, okay, we're going to do the Internet of Things and we put the standards in place. That wouldn't have had the Darwinian evolution of the appropriate standards to form. So we're probably at the right place now where enough companies have tried to establish the standards that would offer them a competitive advantage so that now you can have the opportunity to collaborate, to look at the things that sort of transcend an industry. But I wouldn't want to ever be in a situation where you didn't have that sort of natural competitive pressure put the need for the standard in place. And so I think as a startup company, looking at it strategically, you may choose to buck the trend. If you have a better standard, a better way to spin that system, great, try it. If it fails, okay, you made the bad strategic decision. But it's a competitive environment, landscape that you have to understand and sort of understand that the standard evolution is going to be the same way that your technology is evolving as an industry.
Yeah, and on that point that standards is a loaded term, one of the recommendations that PCAST made to the president was specifically on standards. But when we were talking with the OEMs, they reacted so strongly to that word that what is said in the recommendation is validation, security, and interoperability. So that has become the new understanding of what standards mean for manufacturing.
Less scary. So I want to pick up on any more comments on standards? Then I want to pick up on the issue of collaboration. It is well known in the innovation economy that innovation is a team sport, that the ability for the flow of ideas and technology and people and money are critical to the development and adoption and creation of innovation. So what I would like to ask you to comment on is the issue of the ecosystem in the manufacturing space relative to advanced manufacturing and Internet of Things. What types of collaborations have you seen work? What types of collaborations do you think are missing? And we'll end up with you, Daniel, and you could talk more about the mass robotics, but we'll start again on this side.
Well, for collaboration, Bosch in the United States has a few centers. We've actually got a very small center here that works with MIT. We've also got one out in Palo Alto that's working together with Stanford, one in Carnegie Mellon in Pittsburgh, that looks into some of the raw research topics. I think we're working on materials here in Mass right now. There's a concentration at MIT. Bosch is probably a little bit different than a lot of organizations in collaboration in that it is one of the fundamental principles. I mean, even compared to what I just described here in the US, what goes on in Germany is 10 times that. There's a lot of going on there, and we're trying to grow it here in the US. We're very strong in that. I think back I'm in a lot of trade associations. One of them I'm in is Association for Manufacturing Technology. The Machine Tool Builders Association has a technology interest group, it's called, or Technology Issues Committee, and I chair that committee. And we try to spur smaller manufacturers to collaborate with research, with academia, and so forth, and it was a bear. It very difficult. I'd say it was marginal success. You had few on islands of companies that understood that they needed innovation, that they couldn't work in a bubble, that they needed to work with other people, and they grasped onto it. But I'd have to say that the vast majority of manufacturers had either a fear of the amount of resources, because they were SMEs like you had up on the chart, and thinking, I've got 100 employees, I'm not going to take 10% of them to go work on this, they've got to make things. Or they suffered a little from the I've got a secret syndrome that we talked about before, that I think I'd rather keep this in-house. So for Bosch, I don't see the challenge so much. I hope I'm not looking at myself with rose-colored glasses in the mirror, but I see it in a lot of other companies.
These SMEs, I assume, are part of your supply chain.
They're our customers in many cases.
In
They're
some
people
cases,
that build
customers.
machines, and we buy some of them back. You're right, both ends. I was looking
So
at it
it's
with my
both-
Rexroth
okay,
hand. but-
you're on both sides of
Yeah,
that.
yeah.
But I would assume that if my customer tells me you need to be involved in this, that carries a lot of weight in terms of how I set my priorities.
It does. It does. But there'll be smaller ones that have innovated something at one time or another, or a lot of them will just be, they almost look at themselves too small. They look at themselves as an assembly house or a systems integrator. And really some of the core knowledge that they have, they'll funnel down on this particular type of packaging technology. And there's really a lot of brains in there. And if they worked with someone else, they could really come up with something cool. But they stick right in that area.
Yeah, I think as Scott mentioned, Germany as an area where a lot of this interaction at the federal government company level is very common, right? We don't do that here. But one of the ways where I think we're getting closer, certain states have done this very successfully, is to have the state government be the partner in that innovation ecosystem. So for manufacturing, that means providing, at least in partnership, some high CapEx pilot scale production and test bed facilities. So several states in the US have started to do that now, and that's really brought co-localization of the startups, the supply chain, the funding sources. So thinking about states as creative investors, as partners in this, I think is something that will be part of the new solution for many regions.
So Liz, this is the focus of your study. You didn't get a chance to go through too many of your recommendations, so you had to go through it at lightning speed. So maybe you want to expand a little bit.
Sure. Well, I think this, the point I made earlier about point solutions, I think that captures a lot of what I see in terms of a systems approach to this, which is we have, companies, OEMs solve their problem for their supply chain with their companies, or their R&D question with a particular university on a particular question. And you just go through all of the ways in which we do this on a very relatively small scale and a very isolated scale. So if we're trying to open that up and find ways in which the flow of knowledge and the sort of collaboration happens more freely, I think there are a couple places that can help do that. I think the state can play a role in terms of trying to spawn that or provide incentives or carrots for that. In the German model, the consortium model they have, it absolutely requires more than one OEM, more than one SME, and more than one university. And that's a very different model than what we do here. So I think those have been, and they do often project-based work. So, I think that's a very interesting model. And I think kind of having a strategy that isn't trying to pick winners, but is also, to the extent that we've had these conversations here, understands the 4 or 5 areas that we think are very important fundamentally going forward, and try and bring together some of the leadership around that, particularly around the OEMs. We have examples in this country around particular industries where, Semitech did enormous things for the semiconductor industry. My feeling when it comes to this advanced manufacturing piece is that we actually have to try and pull across industry, so that what we can learn about sensors and advanced materials in defense, medical device, biopharma, whatever these pieces are, that somehow there's some collective learning that goes on that can be done on a pre-competitive basis. So I think that's a big part. And then the other big piece is, how do you push this new technology and new information into the small and medium-sized firms? Continues to be challenging. They don't interact very well with universities. And as much as everyone says, oh, well, they need the latest technology, you talk to some of these top suppliers, they don't want the latest technology unless it's been completely tested, completely validated, and completely approved by their OEM, because that's not going to help them in terms of the standards and sort of what they have to deliver on. So I think this whole question of how we push this information and technology into the supply chains and into the suppliers is really important. Colorado, for example, has just set up this, I think it's being sponsored by DoD, but smart centers. So they pick a number of different locations where they're trying to create a new center that brings all of these pieces together. I'm not sure we need new centers, but I think we need that process of collaboration to happen.
So collaboration is a contact sport, and so you have to allow your people to come together in some ways. So the part of the vehicle for the IMIs is to allow, to have the shared resources where there is equipment, but also people can come together and work together. Part of the model for the MedRC at MIT is we have GE, Analog Devices, Philips, Siemens coming together, visiting scientists from these companies where we're working on things that are probably pretty competitive, but maybe not, so that they have sort of a common language and a common understanding, and some of the barriers to it's our technology, it's your technology go away. They're aware of the walls, but also are working close enough together. And having, at least in the academic environment, having that industry perspective and having industry see what you're doing earlier on actually makes it easier for them to imagine later adopting it, because they've seen how it's evolved. They're more comfortable with what the technology is. And so whether it be coming into a university environment, bringing employees of companies here, or bringing students out into companies, or having another entity like the IMIs, the Innovation Manufacturing Institutes, where employees from separate institutions can come together and work. That's the vehicle, and you need to give the people enough time and enough freedom to be able to do that. And we're seeing that happen, but it's hard to get companies, both small and big, to do that.
You have to overcome the paranoia.
Yeah.
Right. George?
Well, building on this theme of collaboration, one of the observations I've made is that in this collaboration of moving disruptive technology out of the research lab into production, you have to have the right partners. Otherwise, it's not going to succeed. So there are, I think, companies have to recognize that there is a different process that's going to be involved in moving disruptive technology from the lab through a startup into production. It can't be treated the way that a normal large company would deal with a procurement process. You cannot expect a startup company to be ISO 9001 certified out of the gate, for example, and a lot of the other criteria that a large company will use just to qualify suppliers to insert something into their production process. So I think where you have the successes, it's because the companies either have a separate process for doing that, because they understand it, or they have good champions who find ways around the internal processes that exist. But there are companies, unfortunately, that just don't have exceptions, and I don't think they're going to be able to benefit from this flow of innovation.
Chris?
So one thing I'm always surprised about when talking about collaboration, especially for innovation, is that the discussion rarely focuses on the economic benefit of doing so or the economic risk of not collaborating. So the best example I can think of a great innovative environment in manufacturing is Southern China. Southern China was a big manufacturing area forever. It became a little bit stale. And in recent years, you can see a very interesting phenomenon where the traditional paradigm is you make a small number of things in an expensive Western economy, and then when you're at scale, you offshore into a cheaper economy. But today, if you're trying to make a small number of things, tens or hundreds, trying to do so in America is effectively impossible. Whereas if you go to Southern China, you will find people who are jumping at the bit to try and support this kind of small-scale prototyping or small-scale manufacturing. And the reason this has happened is twofold. One is because there is a Southern China Development Fund that has, for the last, I think, 10 years, talked about how manufacturing is moving towards customizability or prototyping or smaller chains. And then the other is because there is a great economic opportunity there that was explicitly expressed and that people are actually looking at.
Daniel?
Yeah, and so this idea of collaboration is so crucially important for us here. It's interesting when you look at robotics and automation in general. Several other regions throughout the world have organized significant efforts to collaborate within their region. I was just on the phone with the New York Robotics Initiative. Pittsburgh has one, Silicon Valley Robotics. And then I'm going in a couple weeks to France to meet with large robotics initiatives from South Korea, China, Japan, EU robotics. And all of these efforts, you see tremendous amount of investment coming, a lot from the government and the industry pulling together. Why? Because they realize that by collaborating and working together as a region, as an industry, they're going to grow that pie significantly. And it's, I think it's rare that we have a situation where we know to a pretty high precision what's going to happen in the future. And this is one of those rare times when we do know with a pretty high precision what's going to happen in the future because we've got a very strong analogous case study. You look at the computer industry, right? And the computer industry started here in Massachusetts. We built these great things called microprocessors, and it really opened up this whole realm of possibilities. Ultimately, we perhaps did not leverage or benefit long-term from that as much as we could have, as that a lot of that went west. This is the exact same situation now. And people like to talk about how maybe robots are different from computers. Ultimately, it's the exact same model. Because in computers, you had a lot of custom hardware. You'd have companies have to go out and write custom software for that custom hardware. Computers, of course, had moving parts. A lot of them don't have moving parts now, but disk drives and that type of thing. This is the exact same model. We can all think about and point out reasons how it's a little bit different. But ultimately, the difference between a computer and a robot and technology, these are all going to evaporate. We're not going to think of them as separate technologies. We're going to think of them as the fabric, the enabling fabric that allows our society to thrive. And ultimately, the thing that matters, of course, is the software. My engineers always get really mad at me when I tell them that, at least my mechanical engineers, when I tell them that robotics is 99% software. And of course, the hardware is important. There's no arguing that the hardware isn't critically important. But the hardware is ultimately an enabling technology for apps. Apps are where you provide the value. When you solve a problem, Uber, great example, right? They solve a real problem. It generates real revenue, real economic benefit. It's the exact same model. So I think we have to get to that mindset of working together, leveraging each other, not trying to build a vertically integrated, we do it all by ourselves type of ecosystem around technology. But really working together to leverage these common platforms and build on them. Why reinvent the wheel? You know, I was on a phone call with an executive at Adept. Adept's another robotics company, and we were actually talking about this elevator integration problem. They're struggling with it. They said, well, you know, we're going to start working on a project. I said, well, you don't need to do that here. Just use our stuff. You can build it yourself. We'll tell you how we did it. And I got a lot of suspicion. Why would you be helping us, right? Like intense suspicion about what are you trying to do here? The reality is if we work together and solve the problems that ultimately are problems, they're friction for technology adoption. If we can work together to solve those, what we can accomplish together as a region, as a nation, as a world, as a race ultimately, moves potentially orders of magnitude faster than if we're all trying to do our own little thing.
And perhaps collaboration is a critical capability of companies that want to be successful in this space. So it'd be interesting to see if the investment community, if the VCs are starting to look at, is this a company that will, in the long run, be good at collaboration if you want to see whether they're going to become a big company, ultimately. I've been hogging the panel here, and I could probably keep them busy for another 3 hours, but I want to open it up to you guys. So do I bring them my mic? Yes. Okay.
Okay, so leave it to the R&D guy to throw the rock at the manufacturing people, okay? So, no, just joking. But actually, I do want to kind of jump on some comments from Kristen and Liz about the resurgence of, say, smart textiles because of these advances in manufacturing and automation. But I also want to kind of tie it to something, you know, Daniel's theme, I think all this throughout this panel is, can't we all get along, and you know, can't we collaborate? So here's the thought. For the past 8 years, I've been working in the emerging markets, and there's one thing I'm pretty confident of, and this is the rock, that our efforts as MNCs to create efficient manufacturing engines to get economy of scale and try and lower our costs, globally, has kind of been a secret failure, because the truth is, it is not allowing our product to get imported to areas like India, where there are high imports and duties, and it's also not getting us in underneath the wires of things like Brazil's local manufacturing policy on public tenders. So here's a three-part question. Because of the technologies we're talking about today, has the age of distributed manufacturing, is it here? And if not, what do we have to do to make it be here? And do you have any examples, small examples of where it is actually happening?
Thanks.
There's a machine where you can order a pizza, and it makes the pizza for you. And they can build as many of those machines as they want around the world. So I think that's an interesting example of where we're going to see machines that build something completely autonomously, and then we'll replicate those in the regions that are consumers of that product.
There are examples of that are now, instead of pizzas, completely customized, not just fabric, but clothing. And that's a distributed model, not because of the fact that labor is cheaper in certain countries than others, which is true, but because the degree of customization demands it. So full body scanner, and out comes your multifunctional smart textile clothing. So that's a distributed manufacturing model that involves robotics, involves software integration, that is taking off. I think it was born of the pressure of the labor prices. But the other issue, in terms of the policy side, that is more difficult, right? Because I think that our country wants to have manufacturing here for all the innovation ecosystem reasons that we talked about. Can we get the price so low that people don't matter anymore? Yeah, in some applications, maybe. But I think in most of the applications, the manufacturing we envision, it's really robot interacting with human. So there is always a human involved. Maybe the model evolves so that human doesn't have to be in the same country.
I'll just follow up. I think it's the MNCs are working in a whole new world. I agree with that, and it's changing. And the only thing I will say is that I'm doing some work in Brazil, and the offsets or the sort of requirements in terms of the R&D investment in that country. It's interesting to me how many, for a while, it's just, window dressing. You had to do this because you had to. But now we see a number of examples where those companies have decided, okay, well, I've got all this capital sitting in Brazil. What am I going to do with it? So they're actually investing in R&D facilities that are part of their global R&D centers. So Siemens, Samsung, GE, all have done this and now the projects, you've got companies, GE, I think, in any case, some of these companies are doing research in which the projects have nothing to do with Brazil, but they're part of this global network. And so ultimately, they will hope to be doing the work in Brazil. But I think that's the reality going forward, and hopefully there are benefits for everyone. But that's just going to happen in all of these countries that are trying to develop the capabilities.
Gonzalo?
Hello. I guess that is for you, Professor Reynolds. In your research, did you study the impact on people and jobs, and what is the reaction on people resistant to change, or not?
Well, no, we didn't. We spoke with companies about innovation. That was sort of what we did. I think but underlying that in terms of understanding how you adopt and how we maximize all of this, is this question of systems and people and change. And one of the biggest challenges in our ecosystem here in manufacturing has been this perception issue, which is the next generation doesn't want to be involved in manufacturing. They think that there's something wrong with it. I was talking with the former head of the SBA, and she said she went into, she's meeting with parents, and they said, I don't want my kids involved in manufacturing. I want them involved with computers. So, there's a whole perception there. So that, I think, is a huge change for this country. And also, if you think about our education system, the vo-tech schools have been kind of pushed aside. How do we bring them back in? Our community colleges. So I think that we have to change our perceptions on this rapidly. And obviously, there's a lot of concern. There's a lot of anxiety about the global competition and how we address that. And I think the only way, in my mind, that we do that is we try and. I don't think we should shy away from the technology or shy away from the innovation. We have to bring the system into it better. We need to integrate those, those pieces better to really address that anxiety.
Do you have questions for any startups in the room? Early stage companies, growing companies.
How about reflections from Ted, who's seen this?
Ted?
Call out.
I'm not sure if it's a question. There's probably a question somewhere in here, but since I don't have it yet because you put me on the spot, but maybe a bit of a story. So we followed, I think what I'm learning is sort of a typical progression as you start a manufacturing operation from zero. Part of our innovation is some of our point solutions that we developed, our own CAD design software tool that we use uniquely for our product, our own robotic manufacturing work cells that we use uniquely for ours, but we also use QuickBooks off the shelf and other products off the shelf. And we were stitching those together around a hub, but we never had a center hub. And we realized a couple of years ago we needed something to connect all the information together. So when our CRM, we get some customer data, and that goes into our design department, we can share that data across. It was literally like SneakerNet and rekeying, and it was getting ugly as we scaled. So we said, well, we need to get an ERP system, and we don't want to invent our own if we can avoid it. So we hired 6 different consultancies ranging for small little pilot studies to figure out which of them would come up with the best proposal that we would then hire them to build it for us. Because we knew we needed them to dig in. We had to give a little bit of time so they could really research and develop a solution for us. So Microsoft backed out with the Great Plains solution platform. They said our mass customization model didn't fit. It wouldn't, like their solution couldn't do mass customization the way we were doing it. We talked with some like .NET framework developers and some others. None of the solutions that were out there were going to work for us. So we actually went with the most risky, non-manufacturing ERP software developer group we found, and sort of explained to them what ERP is, and then they built it for us. And it's now cloud-based ERP. Everything's connected together. It's all through APIs and RESTful, like all the most contemporary modern connectivities and technologies that I'm learning about.
And it works.
And it works great. And we're a silo, so we're not going to be connected. Like, I guess we can. We still can't connect to QuickBooks because they're so difficult to interface with. So I'm not sure what our path going forward would be, but I guess that's an observation. I'm not sure where the question is, but maybe the question is, where should we go next as we scale? Should we continue developing our own system? Should we just keep doing that and add interconnectivity to it so that as we find ways to collaborate, we can just connect sockets? Or should we eventually mature and get rid of our own solution and buy something later?
So there's at least one ERP system on the earth that is working to the satisfaction of its owner. I'm really pleased to know that that exists. Any comments on that?
Well, actually, I wanted to just follow up on this gentleman's comment very, very briefly. And I appreciate him calling out the elephant in the room, of course, and the whole race against the machine issue and all that. I had a group of executives from Toyota recently visiting, and we were talking about the graying of the workforce and all of those problems. And they're investing a tremendous amount of money into trying to build robots to take care of grandma and grandpa. Incredibly difficult problem. And we also see a lot of AI being invested in trying to build robots or technology that can have a conversation with grandma and grandpa to make them think that somebody cares about them, to have a relationship. This, for me, is a travesty. And what I think is going to happen ultimately is that we're going to have technology do the dull, the dirty, the boring stuff so that we can have time to do the meaningful things, right? That we can have time to take care of each other. Technology is going to drive labor prices down, and care is going to become affordable for more people on this planet. So I think it's important that we focus the technology on the right problems. And for some reason, we always tend to jump to these, let's build this humanoid robot that's going to help grandma get in and out of the bathtub. Well, that's something that we really should take responsibility for as a race. Are we really going to build a machine to do some of the most intimate things that we should be doing for each other? I think that that's an important consideration to think about. But it's an important conversation for us to have. How is the economy going to work? How are people going to earn a living? How is it going to be okay for people to contribute to the human race in ways that we perhaps don't think of as traditionally adding to the GDP right now? I don't know the answers to that, but I think it's an important conversation that we need to start having.
And I think it's an incredibly important point and a great point to end the panel on. But perhaps it's a good topic for a session in the fall to talk about that question about why are we doing this and how do we do this in a human way. But please join me in thanking the panel. They did a great job. Thank you.
Before we end the session, I just wanted to check if someone has found a special friend, perhaps a digital friend, perhaps a robotic friend. It doesn't have to be, it could be a representation of a real friend. And I think that there are some limits here that we need to talk about, right? So it's not either or. So there's cyborgs. So this debate will continue. Thank you so much for your attention. I really hope that you got something out of this that was tangible and close to the topic. Thank you to all of the panelists. Thank you to everybody who contributed. Special thanks to Margaret Wells, who is time and again just really working very, very hard to make all this happen. And see you again in September. Please spread the word about Startup Exchange at MIT. Thank you.